Hello everyone, I am Srikanth from CSM department, Marri Reddy Institute of Technology and Management. Today, course outcomes are students able to understand and learn about different computing paradigms and know fundamentals of cloud computing and its characteristics, and understand the way in which the cloud computing could be programmed and deployed, and know about different cloud service providers. The today's lecture agenda is high performance computing, parallel computing, distributed computing, and cluster computing, grid computing, biocomputing, mobile computing, quantum computing, and optical computing and nano computing. First of all, what is a computing paradigm? A computing paradigm is a fundamental model, approach, or style for organizing, designing, and performing computation to solve problems. Uh, the definition of computing paradigm is a consistent approach to computation, data organization, and a system design. The definition is a consistent approach to computation, data organization, and system design. The purpose of computing paradigm is to solve problems efficiently by providing a standard set of practices. Next, evaluation. The paradigm change based on technological advantages, advancements. Sorry. The evaluation of computing paradigm is change based on technological advancements such as moving from centralized system to distributed systems. Here, the paradigm change based on technological advancements like as moving from central systems to distributed systems. Okay, focuses on performance, scalability, and efficiency, and last one, innovation. Next, high performance computing. Here, high performance computing uses clusters of powerful processors working in parallel to solve complex and massive or time critical computational problems. It speeds millions of times faster than traditional computers. Next, it integrates advantages hardware and CPU, GPU, and high speed networking and storage with specialized software to run simulation modeling and AI tasks. Next, used in forecasting and climate modeling and speech research. Next, parallel computing. Here, parallel computing is a method where large complex problems are broken into smaller tasks and executed simultaneously across multiple processes to boost speed and efficiency. Here we are seeing here we observe the clients are different types of clients are there, and different types of databases are there. Okay, but here only one server. Here the benefits of parallel computing is reduces execution time and serves resources by using multiple processes of simultaneously. Next, the types of parallel computing. First one, data parallelism, and second one, task parallelism. Next, the need for cloud computing. Here, the cloud computing is essential for modern businesses offering on-demand access to computing resources over the internet. Next, eliminating the expensive upfront hardware costs. Here, mainly we have to use the cloud computing is essentially for modern businesses and offering on-demand access to computing resources over the internet, and eliminating the expensive and upfront hardware cost, and the reasons for the need for cloud computing. First one, cost efficiency. Second is scalability and flexibility. And third one is accessibility and remote work. Okay, next, fourth one, disaster recovery and data safety. Next, speed and innovation. Next, global reach and low latency. And last one is advanced technologies. Okay, here 1 2 3 4 5 6 7 reasons for need for the cloud computing. Okay, next, cluster computing. First of all, we have to know about cluster computing. What is mean by cluster? Here, cluster computing is a powerful distributed architecture where multiple independent computers and known as nodes. Multiple independent computers are known as nodes are linked with a high-speed network. Linked with a high-speed network to act as a single. Here we observe that the diagram is act as a cluster computing. Here we are here the root node is this computer, and from this root node it has so many children nodes. First one, first children, second children, and third children. Okay, here first children node and second children node and third children. These these children nodes are connected with this main root node with via internet. Okay, through internet. Here we are giving to the root node. We are giving to the input to the root node, and root node will share this workload to the children nodes. Okay, children nodes. Here the result come from the root node only. Now, grid computing. Grid computing is distributed system that connects geographically dispersed heterogeneous computers to act as a virtual supercomputer. It's enabling collaborative processing of massive complex tasks. Is nothing but is a distributed system that connects geographically dispersed heterogeneous computers to act as a virtual supercomputer. It's enabling collaborative processing of massive complex tasks. Okay, by pooling ideal resources. It provides cost effective, next, high performance computing for scientific simulations and financial modeling and task analysis. Okay, now used for large scale scientific projects and data intensive tasks. Now, biocomputing or biological computing. Biocomputing or biological computing is an industry. Now, biocomputing or biological computing is an interdisciplinary field that uses biological components, for example DNA and proteins. Next, cells. Okay, here DNA and proteins and cells to perform computational tasks aiming to simulate a mimic living organism. Okay, here it uses biological molecules for computation, and the DNA used to store and process the data, and highly efficiency and highly energy efficient also. Okay, next, still in research stage. The biocomputing is still in research stage only. Okay, the biocomputing potential applications are: first one, medical diagnosis; second one, genetic analysis. Next, mobile cloud computing. Okay, here mobile cloud computing. Next one is the mobile cloud computing. It combines cloud computing with mobile technology. It combines the cloud computing with mobile technology to deliver applications, data storage and processing power directly to mobile devices. The mobile cloud computing, it combines cloud computing with mobile technology to deliver applications, data storage, processing power to directly to mobile devices. Next, reducing reliance on the device's own hardware. Next, this infrastructure enables high performance apps, seamless data synchronization, and increased battery life for users. Next, quantum computing. Quantum computing is nothing but an the quantum computing is an emerging technology that uses principles of quantum mechanisms, especially superpositions and entanglement, to solve complex problems for beyond the capacity of classical supercomputers. Next, using qubits that can exist in multiple stages simultaneously. It uses qubits instead of bytes. Okay, these systems offer exponential speedups for optimization, cryptography, and molecular simulations. Okay, molecular simulations. Here, based on quantum mechanisms, and it uses quantum computing uses qubits instead of bits. Okay, it performs multiple calculations at once. Okay, next, extremely fast for specific problems. Now, the quantum computing applications are cryptography and drug discovery. Next, optical computing. Here, optical computing or photonic computing. Optical computing or photonic computing. It uses photons from laser or diodes rather than electrons. Here, optical computing uses the photons. Photons means light beams. Okay, light beams. Here, light beams from laser or diode rather than electronics. Okay, to perform data processing, storage, and transmissions. Here, the optical computing uses light instead of electricity. Okay, light instead of light. Optical computing uses light instead of electricity. Okay, next, it faster data transmissions. Next, low heat generation. Next, used in fiber optic communication, high speed data processing. Next, the quantum computing is still under processing only. Okay, nano computing. Nano computing refers to the design and uses of extremely small and nanoscale devices to perform computing tasks. Okay, next, often utilization moleculars, mechanical and chemical, or quantum technology. Here, nano computing refers to the design and uses of extremely small nanoscale devices to perform computing tasks, often utilizing moleculars, mechanical and chemical, or quantum computing. Okay, the quantum computing at nanometer scale, it uses nano-sized components. It uses nano-sized components, extremely smaller and fast. Extremely smaller and fast. The applications of nano computing is medical nanorobots. The applications of nano computing is medical nanorobots, and next, advanced electronics. Thank you.